Wait, that's the first close-up picture of Mars?
It is. Well, the first one humans received. And yes, it looks as though someone photographed a television during a power cut.
That tiny gray edge had spent more than 7 months traveling on Mariner 4. The spacecraft flew past Mars on July 14, 1965. By late July, the full result was becoming public news. No city, no canals, just a real place finally seen up close.
But it did not send photographs the way your phone does. Its camera made a grid, 200 by 200 dots. Each dot got a number from 0 to 63, from white to black. 40,000 numbers for one picture.
And one picture took about 8 hours to reach Earth. 8 hours. Today, I get annoyed if a photo takes 8 seconds.
The signal had crossed roughly 134 million miles. Deep Space Network antennas caught it, and teletype machines at JPL printed pages of numbers. The computer could rebuild the image, eventually. The people in the room were less patient.
So, they bought pastel chalks, assigned a color to each number, and filled in the strips by hand. The first close-up picture of another planet became an enormous color-by-numbers project.
Which sounds almost comical until you see them doing it. They were touching data that had come from Mars.
The first frame only caught the planet's edge. Then, more frames arrived. On picture 7, the craters became unmistakable. Picture 11 showed a huge scar, later named Mariner Crater.
Mars looked less like the world imagined in old maps and stories, and more like the moon, ancient, cold, and battered. The atmosphere was far thinner than many researchers had hoped. Mariner 4 found no detectable global magnetic field.
So, that was it? Mars was a dead crater ball?
That was the reasonable first impression. But here is the part people often miss. Mariner 4 photographed less than 1% of the surface. 21 complete pictures and a sliver of one more, all along one narrow path.
Less than 1%? Imagine seeing 22 phone photos from Earth, all taken across one desert, and deciding you now understand the whole planet.
Exactly. The pictures were real. The craters were real. The mistake would have been treating a narrow sample as the final answer.
6 years later, Mariner 9 did not just pass by. It entered orbit. A planet-wide dust storm blocked the view at first. Then, the dust cleared, and Mars changed again.
Mariner 9 returned more than 7,000 images and mapped about 85% of the planet. It found giant volcanoes, a canyon system stretching across a continent, and landforms shaped by ancient water.
So Mariner 4 was not wrong. It was the first page of a much longer book.
And that may be the real achievement. Before Mariner 4, Mars could absorb almost any story we projected onto it. After Mariner 4, every story had to answer to measurements.
Today, we can watch a spacecraft descend through the Martian sky in full-motion video. The comparison is almost unfair.
But every sharp modern frame belongs to the same chain that began with a noisy signal, a page of numbers, and a group of people too excited to wait for the computer.
22 tiny frames did not finish the story of Mars. They did something better. They made the story testable.